So my name's Kevin Wilhelm. I work for Eli Lilly and Company. I've worked for them for 27 years. All that time has been in engineering. And as we go through this conversation, I guess I would say look at this as a use case, and I'll try and point out some of the IT, OT, ET convergence aspects both that we applied through this study and some of the opportunities I see for that convergence in the future. So just a bit about Eli Lilly, if you don't know, we're a pharmaceutical company. And basically, as I explain it to my kids, my neighbors, my colleagues, we make medicine for a living, and so that's what we do. And the next slide gives a little bit deeper overview of that we're a company with a strong heritage, a long horizon. We have 41,000 employees. Would say we have about 1,000 engineers in our company. And one of the things that I would say that's important about pharmaceutical companies is that we have both process and batch types of plants, and we also have discrete manufacturing plants. And I don't know that everybody understands that, but we have, and they're very different kinds of plants. So in our industry, we have those types of plants and those types of challenges, and a lot of times we compare and contrast those types of challenges and those types of designs, those types of opportunities against each other. I'm gonna try this again. So this is a slide that a lot of times I try and present to our leadership to explain a couple different things. So one is, as you can see, I've listed out how I view the different engineering disciplines and how old they are, right? So folks were building pyramids a long time ago. The first PLC automation, if you can define that as the seminal moment, was 40 to 50 years ago. So my point is a couple, that one, I believe that we're very early in the adoption of this computing technology, and that if I look at the S-curve, we're at the steep part of the S-curve. And so I also point out that this million-fold increase, I was trying to wrap my head around what's a million-fold, right? And so the example I use there is if I had a bridge that's a mile long, right? So civil engineers have built bridges. So if a bridge is a mile long and if the moon's 250,000 miles away, our civil engineers would have had to scale their bridge designs from 1 mile long to 4 times the distance of the moon. So that's the computing technology kind of change that we've seen. And that's how I start to wrap my head around what's a million-fold increase look like. From a Moore's law and process control perspective, I can think back over my 27 years when I started at my first plant site. We had push buttons and pilot lights and panels. We had pneumatic controllers that we were starting to, that were at the end of their life cycle, and we were replacing those with distributed control systems. We had SCADA systems that were very proprietary and closed. And so I can follow through from a process control perspective that Moore's law as well. And I guess one of the ideas that I have around IT and OT convergence is around mid-90s, we had things come in like Windows for Workgroups for some of our SCADA systems, right? We had Windows NT start to come in. And so for me, that IT convergence with my automation technology started to happen about 20 years ago or so. As soon as they got off their closed proprietary systems and went to some of these open systems that were coming out of the consumer markets, that's when that convergence starts. So I see it as a journey of 20 years, not something that's new. So one of the problem spaces that we have is how do we maintain our automation assets, and how do we do that the most cost-effective way? And so you can see some of the list of the typical struggles that would not be unique to Eli Lilly. They would not be unique to pharma. There we go. So there's a couple different aspects around that. So I have a couple different examples that say, so we have this kind of technology complexity thing that's fighting against us here as I look at these problems. And you can see that example is I have one component that's buried deep in some subsystem within some overall system, and as it goes out of its life cycle, it cascades into a series of problems, right? And my IT organizations have ways they deal with that because they kind of do an economy of scale thing, right? So they go through and they replace keyboards kind of en masse or monitors en masse and all. But for my automation systems, I don't necessarily have that luxury. I don't have the luxury to go in and all my plants are not operating on the same production schedules. They don't have the same assets. I may have bought plants, I may have sold plants. So I have more variability, if you will. So some of the IT techniques that they would apply to this space don't necessarily apply to me. One piece around pharmaceutical that I also would like to add is that I've heard this stated a couple times, is that we don't make changes. We can't make changes because our plants are either certified or validated or qualified, whichever word you like to use. And so I would say that is absolutely not true. We are making changes every single day, right? So now we have a set of business processes we have to follow around change management, configuration management, document management, regression testing if required, but we have to go through those, but they're very disciplined engineering processes. So that's one of my first engineering technology convergence examples is that we are applying a lot of very disciplined engineering technologies to how we manage our pharmaceutical plants. And then some of those examples that I just mentioned are coming from our IT colleagues, right? Things like source code management, things like configuration management. So back to here's a use case. Those are some of the IT and engineering convergent items that we're feeling in our automation space. Okay, so here's a standard Purdue reference model, ISA S95 model, whichever way you'd like to describe it, right? So we have that as a reference, if you will, at Lilly. And so if I kind of do where were we yesterday and where are we today, at the bottom layer in general, what I see as an engineer is that it's not that much difference from a functionality perspective. I'm controlling loops, I'm doing sequencing, it's chugging along. If I have a system that's 10 years old versus 20 years old, it's not behaving that much differently for me, to be quite honest, okay? But the upper level, the level 2, the level 3 systems have had huge functionality changes over the last 20 years, huge. And I've also had these huge technology changes over the last 20 years as well. And so from a lifecycle management perspective, I kind of have two things I'm fighting against. So at the top level, I went from, let's say, a 10-year, these are all arguable numbers, right? But I went from about a 10-year life cycle, it felt like, where I was replacing these closed proprietary systems, to now I'm on a much shorter life cycle, about 5 years. But every 5 years, I need to go in and do some sort of major intervention on my plants because of that IT technology that's in that space. Down below, again, these are arguable numbers. I have plants that have technology at that layer that have 25 plus years, so these are not notional numbers. But I have seen some shortening. I have a couple examples. There was some different examples around the restriction on hazardous substances, and so that got into the supply chain, for my suppliers. The suppliers said you're going to have to evolve away from these particular components or parts. And so I do think that shortened some. But in general, it's not changed a bunch. So the two problems that I have as an end user is the top space to me feels very chaotic from maintaining this. And so every dime, every hour that I spend just maintaining a system, quite honestly, is an hour, a dollar that I don't spend optimizing that. It's an hour that I don't spend, or a dollar that I don't spend trying to adopt some of the newer technologies. So if I can get this problem to go away, I will take that investment, so investment says time, that money, and apply it to some of the newer technologies. So that's one of the things that I've observed in this conference is that we have this huge technology advancement that we've done, this million-fold increase, right? But we really haven't advanced necessarily the people and the processes at the same rate. And so yesterday we were talking through with some of the cybersecurity folks, and they had the same observation. The technologies here, our ability to manage the technology, our ability to have engineers coming out of school are not at the same points where our technology is advanced to. And that's something that I think we collectively need to work on. And as an end user, it's one of the things I'm asking for help. How do we get those people, how do we get those processes to be at the same level of maturity, the same level of pace of change as the technology is? Down below, I still have this problem. We've been talking about it in a variety of different ways, but I have this stability until it's not kind of problem, right? So I have this kind of massive replace. And so one of the thoughts there, and I guess one of the maybe a way to think about that, a lesson that we have at Lilly is, I don't know that's necessarily always a bad thing, because if I have a plant that's say 20 years old, I've learned a lot about that plant over 20 years. I've learned an enormous amount of things, right? And so a lot of times what we do is we have a small project team that goes off and chews off 10, 20% of that plant and works on it and migrates it every year. And you have a 5-year, maybe even longer, maybe a 10-year program, right? And so we don't just replace that control system for the plant. When we go through, we optimize it, right? We're finding the bottlenecks. We're finding the things the operations groups don't like. We're finding the things that our tech service or our engineers that look at the data and the science around it, the things that they'd like to get out of that. We can add additional batch context. So there's a lot of things that I can do as I evolve that plant. So for me, one angle to look at could be is that maybe that's an opportunity I don't want to necessarily run away from and try and do this, get away from always not replacing my systems. Maybe there's a way to evolve those systems to take advantage of the learning that I have over the 20 years. Again, a bit different perspective, but I do get value out of going in and having those small teams replace components, parts of my systems, and optimize that part of my process. Okay, so just go backwards here. So the challenge that a team that I led for last year basically was, how do we deal with this kind of maintain our automation assets? How do we spend less time on it? How do we deal with some of these concerns that were listed earlier around patching and cybersecurity and those types of items? And this was the charter. I think the important part, kind of back to the use case around IT, OT, ET convergence, is that this was a charter that was equally sponsored by both IT, manufacturing IT, and automation. It was equally staffed by both those groups. And so we were intentionally putting those groups together to work on this problem space. So that's, again, another example of that working together, collaboration, partnership in this particular space. So as I transition to the next part of the presentation, what you'll hear me kind of repeat over and over and over again is these 4 key areas. And so there's not a lot of magic around those key areas. We were just trying to take this space of how do we deal with this and break it into some pieces so that we could focus in on the pieces. So we could have picked maybe 4 different pieces, but these are the ones we picked. And I'll talk about each one of those in more detail. So these are a little bit more details about each one of those pieces. I think one of the other things that that I learned about this particular space is that it's a pretty complex problem when we got into the details of it. And I think there's some things that we have yet to learn, and I'll talk about this around the architecture piece, especially with regards to things like system engineering approaches, complex systems. How do we think about those types of things? Back to the technology advanced beyond where the people and our work processes are. And so how do we think about a problem like lifecycle management that has a lot of complications when you start digging into the details? So, but to summarize the 4 areas, we have an inventory area. You can read through that. Again, I'll talk more detail to that. We have an architecture area, and we have the kind of assessment and planning and recapitalization and those types of business processes. And then lastly, as we work on these, one of the things we're also trying to do from a collaboration perspective is to make sure that we work with our key vendors, key suppliers, because maybe there's some things we would be asking them to do to help us from a product development perspective and those types of items. So, architecture. The experts that I would say that we worked with, and one of the things that the IT folks brought to the table was their ability to talk about architectures. Okay, they're used to having that. They have these big enterprise architecture models, et cetera. The problem is quite honestly, I don't know that I understand them very well, because I wasn't trained in that. So I was thinking about how I would explain that to my IT colleagues, and it's kind of like if I started talking to them with my background in process control about Laplace transforms, or heat transfer, or those types of items. So it feels like I'm being explained something that I don't really understand and wasn't educated on, okay? I think the other thing around architectures is when I do some digging around on the internet, I find things that are more engineering related types of frameworks for architectures, right? Things like decision-making frameworks. I have some software aspects in there around reusable code. There's some ideas where I would want to try and reference external standards. And so I think this is an area for Eli Lilly we're trying to learn, and at least what I've learned so far is my IT colleagues don't totally have the answer here, or at least they haven't shown that answer to me yet. And so part of what I'm trying to do at this point is really reach out to some of my engineering colleagues and say, so I have a more complicated modeling problem here. From a systems engineering perspective, can you help me advance this idea that says my reference architecture is more than what my IT folks think it is? I think the last statement I would say is that as I look at that and I think about convergence, that certainly is not a process control engineering problem that I've been trained to solve. It's a very different kind of problem as I look at what those types of items are, how to build a framework like that. That is not a problem of a Laplace transform would resolve. So one of the things I have learned from our IT colleagues, and also from some engineering experiences I'll refer to later on, is that they are outstanding at terms of governance, at least at Lilly. They have the different forums, they have the different roles and responsibilities, they have consultants in key positions in their organization. They have their management appropriately involved in the management space and not necessarily consulting as experts in the technical space. And so that's one of the things that we're leveraging from them is how do we take those learnings and those things they've applied in their IT space and apply those more in the automation space for ourselves. And so that just summarizes kind of the various groups, if you will, because I know it's a very small font, right? But it summarizes the different groups that I just referred to: management, technical consultants, the groups, the reference architecture, and then ultimately a site architecture that people can implement against. So remember, there's kind of this three-legged stool that I've been talking about, right? That was in our kind of goal statement, maybe 3.5. So there's assessments, there's architectures, or inventories, yeah? So when I think about inventories, and as we thought about inventories, we came up with a couple different ideas, solutions. So the first thing is when I talk about inventories, the cybersecurity folks in IT love me, right? Because they're like, oh, you guys need inventories, and we do. But I think they don't necessarily have the same exact use case that I do, because when I'm talking about inventories, I'm trying to figure out how do I deal with my obsolescence problems. When they're looking at it from a slightly different perspective, which is how do I deal with some of my security risk problems. So that's one observation, is that we've had to be more clear as we work with our IT colleagues. It says, well, what's the purpose for the inventory? And those use cases have some different design considerations and potentially some different design implementations. I think the other thing that we acknowledged is that our IT colleagues, again, are also working on inventories from assets they have. As I virtualize items to put them on their servers, they have inventory tools where they're going through and looking at all their various assets. So they're developing inventories themselves. And then as we also looked at this, we know that we have a computer maintenance management system that has inventories and has spare parts, has components in it, has all those types of items. And so as we thought about inventories, what we came up with really was this convergence, if you will, of IT, OT, or automation, and engineering in that case. And as we think about inventories, we really need to think about that stack of what those are, where we want those source data points to be in those various tools and repositories, and how we want our engineers to use those as a holistic set of inventories and not just have an inventory. One challenge I would say that I have is that, and this is a new thought, so bear with me for a moment, but as we talk about the industrial Internet of Things, one of the things I'm wondering why I don't have is I have a whole, hundreds of thousands of components. It would be really nice if those things were self-aware, if they could tell me whether they have obsolescence problems or not, and that was an open system, not a set of closed systems. Self-report in what my assets are, self-report in what the status is against a lifecycle model where there's some data from the various suppliers, and do that as a comprehensive whole, not as a series of subsystems or subcomponents. And so I think I would summarize that as, is there a way that we can eat our own cooking as we talk about the industrial Internet of Things? Okay, so we have the three-legged stool: inventories, assessments, and architecture. So on the assessment leg, one of the interesting conversations I had with one of our engineering directors at a plant site was, the conversation was something like, we struggle in automation justifying our upgrades, right? They don't always make the cut. And why is that? And his very candid response to me was, he goes, well, I'm a chemical engineer. I can go out to the plant and I can see the rusty tank. I go out to the automation systems and I see a computer and the lights are green and it was working yesterday, it works tomorrow. Why do I need to spend money, right? And so the lesson I learned from that is I think that, again, we should leverage our IT colleagues because they have better models in terms of explaining what that obsolescence state is for those computer systems, and better ways to maybe express that to our leadership, because they're justifying those upgrades already to other parts of our business. So this is a way to compare the two different parts of our manufacturing. As I referred to earlier on, I have a set of plants that are street manufacturing, and I have a set of plants that are more process and batch oriented, right? And so this is a notional model or a nominal model that shows kind of where the maturity are. And again, as I use this as a use case around the convergence of these various technologies, the genesis that I'm aware of in terms of these maturity models is I go back to my Carnegie Mellon software, capability maturity model book that I have from the early 90s that somebody gave me. And I pulled that out as I looked at this and thought through this and built this maturity model. The other thing that comes out to me is that, if I have systems that are managed as systems, it becomes, from a lifecycle management perspective, easier for me. And so I can see that in terms of these DCS systems that are more monolithic. They're more managed as an overall system. And I can also see that if I have thousands of these PLC-based systems that are somewhat asynchronous, come with different vendors, some come from skidded equipment, those types of items, I have a much more volatile situation to try and manage. I think the other observation on capability and maturity models, and this may be obvious, but you'll notice not everything's at a 4 level. And so I think as we apply some of these different models, for me, the other observation that was helpful for using that capability maturity model was not necessarily striving to be great in every one of these categories. In some categories, good is good enough. For me, the technology where we have the business processes, for our architecture, that's where I'm going to do things like look at new technologies. How do I adopt new technologies in or not? How do I make those decisions or not? So that is, for me, the reason that it is something that I want to be able to continuously improve that particular work process, because I think that's where I'm going to be able to incorporate in things like augmented reality, cloud-based applications, those types of items is where I'm going to fit this into this business process. So we're still on the third leg of the stool, so the assessment. And so this was a model that I picked out of a public document out of a manufacturer consortium out of Germany, and I have a reference for that later on. But the interesting thing as I looked at that was, and I think this is part of the feedback that I got from the engineering director on the rusty tank example, was that I need to be more agile in my thinking around our obsolescence, right? So I have an example where we went into a plant site and we did an assessment, and they were originally suggesting that they wanted to replace some of the older control systems. And we started asking some questions that may seem obvious at the moment, but maybe they weren't asking the right people or in the right way. But the questions basically went, how long is that facility going to be used? How long is that process going to be in place? And as we started asking those questions, we started kind of going to a more spare parts oriented type of support model, so that we could extend the life of that asset versus do some sort of a rip and replace. And so again, that may seem obvious, but I think the point is, if I can show to my engineering colleagues this decision-making criteria that we're utilizing, then I can build some of that trust and confidence. And that's what they're looking for, and quite honestly, that's how they're applying their decision-making to these other parts of the assets in our plants. So I won't walk through these, but those are listed in terms of the presentation, which will be available. So if this is somewhat interesting, some of these external benchmarking points, those are listed for folks to consume. Those are all publicly available. And to summarize, I would say that the approach that we took to this problem, again, was we broke it down into some digestible pieces. I believe, did a lot of collaboration and partnership with both our IT colleagues, our engineering colleagues. The word that I will use, that another engineering director uses, that we were attempting to decomplexify things, because the space for us as we got into it was not well understood, and our business leaders were giving us that feedback. And so I would leave it at that I think part of the engineering technology component in this convergence is how do we apply good engineering principles. And part of those good engineering principles are taking things and breaking them into digestible parts that we can explain to ourselves, explain to our business leaders, and the test case I usually use is, could I explain it to my neighbor, right? So with that, thank you for your attention. I appreciate that, and Paula, it's back to you.